Good morning. Thank you all for attending Passkeys 101 and the introduction to the white papers. My name is Dean Saxe. Thank you again to Megan for the introduction. I'm a senior security engineer with Amazon Web Services. I'm actually an embedded security engineer within the AWS identity team, where my focus is on protocols and standards, particularly around authentication and authorization. And it is through that work that I actually serve as the co-chair of the FIDO Alliance Enterprise Deployment Working Group, also known as the EDWG, where we focus on how enterprises can deploy FIDO-based solutions in order to solve their most pressing authentication needs. And so what I'm going to talk about today is a bit of introduction to passkeys. We'll start with a bit of FIDO authentication in a nutshell. We'll then talk about what a passkey is, because a passkey is a subset of FIDO authentication mechanisms. And we'll discuss the security spectrum of passkeys, because not all passkeys are created equally. Not all passkeys meet the same security bar. And that's quite okay, but it is imperative for us as deployers to understand some of those differences to be able to choose the right passkey for the right situation based upon our security needs, our regulatory and compliance needs, etc. I'll show a couple of videos of the user experience using a passkey to log in through two different mechanisms. And then I'll give a very, very brief introduction to the white papers that we're introducing before turning it over to the authors for them to talk about their white papers, the information presented within those papers, and the conclusions that they've come to. So let's get to it. So without going into the metrics that are here on this deck, I think it's imperative that folks understand that our foundations for authentication are really fundamentally flawed today. The use of knowledge-based authentication factors, such as passwords, and other factors, second factors such as OTPs, whether delivered via SMS or email, or even via a virtual authenticator app, all of these kinds of credentials are still easily phished out of our users or otherwise socially engineered out of our users. And they create challenges for users to manage and maintain these kinds of credentials over time. And this is, in fact, the root cause of many of the vulnerabilities that we see on the internet today and many of the common attack patterns. Many hacking-related breaches, 81%, are caused by weak or stolen passwords. And so we fundamentally have to change how we manage authentication online if we're to reduce the risk to our end users and to our enterprises. And so FIDO authentication is one mechanism that can allow us to do this. And the way I like to think about this is by doing a bit of comparison with between passwords and FIDO to demonstrate some of the differences in why FIDO-based mechanisms are much stronger and more reliable authentication mechanisms than passwords. So let's start with passwords. So passwords are, generally speaking, human-generated symmetric secrets. And not all are going to be human-generated. I, for one, certainly use a password manager in my daily life when I need to use passwords. But many of these, or maybe even most of these, are generated by humans. But the most important part here is that they are symmetric secrets. And as symmetric secrets, that means that I have a copy of my secret, my password, and the service that I'm using, the website, or we may call it a relying party or RP, also has a copy of that password in most cases. Now, there are obviously transformations that RPs are going to make to that password, such as turning it into a salted hash in order to protect it at rest. However, it is still a copy of that symmetric secret. But the further problems come from the fact that we're human and we're fallible and we make mistakes, such as reusing the same password across websites or using a form of a password that maybe changes with the year or the season or is otherwise reasonably predictable. And these reasons mean that once these passwords have been leaked into the wild, they can be used in things like credential stuffing attacks to attack services and attempt to use passwords that are known to have been used in the past in order to authenticate to accounts, potentially for account takeover or financial abuse or other kinds of fraud. Additionally, because these shared symmetric secrets are used by humans, they are also phishable or otherwise socially engineerable out of those humans. And so I may be sent a link to a phishing site that looks very similar to FIDOalliance.org, but is in fact not the FIDO Alliance site. And if I am not cognizant of the differences and aware of where I am entering this password, that password and maybe even an OTP could be stolen and used to log into the legitimate site and then take actions on my behalf. And finally, because these symmetric secrets are shared with the relying parties or services that we're using, they may also be leaked from those relying parties. Now, in contrast, FIDO does not use symmetric secrets. FIDO is based on public key cryptography or asymmetric cryptography. And there's a private key that is retained within the authenticator and a public key that is shared with the service. But that public key can never be used for authentication. So even if I was able to steal that public key from the relying party, it would be useless to me because I cannot use it to actually generate responses to the protocol on behalf of the user and authenticate with that public key. I need that private key. But further, the FIDO credentials are what is known as origin bound. That is, they are bound to the DNS name of the service that they have been created for. So the credentials that I create for FIDOalliance.org cannot be used on FIDOalliance.com or other misspellings of the FIDOalliance.org site that may be commonly used by phishers. And this makes them highly phishing resistant. Both the browser and the authenticator will not allow me to use a credential for FIDOalliance.org on a site that doesn't have that same DNS name. And as I mentioned before, even if we obtain the public key from the RP, we are unable to use that public key for any authentication events. So that becomes a useless attack pathway for actors who seek to compromise accounts. But how does the FIDO protocol actually work? So on the left, we have a client, and on the right, we have a relying party server. You can think of this like a web server. And there are messages sent back and forth between these two. So the client, and you'll notice this is all going to be in italics for the client, says, I'm ready to log in. The relying party, whose answers will all be in bold, says, okay, here's a challenge. And this is a random challenge that is sent to the client. And this is the beginning of our challenge response protocol. The client, in turn, signs that challenge with the private key located on their FIDO authenticator. The relying party server uses the public key that has previously been registered for that user in order to validate the signature over the challenge. And if the signature can be validated, then the user is authenticated. And it is this set of interactions that is used in order to authenticate users, and a very similar set of interactions is used in order to generate a new credential for the user when they are creating whether it's a passkey or other kind of FIDO credential. So let's dive a little bit further into this and talk about what a passkey is, because a passkey is a subset of the set of FIDO credentials that are available. And I'm going to offer you two definitions here. The first is a marketing definition, which is that passkeys are a replacement for passwords that provide faster, easier, and more secure sign-ins to websites and apps across users' devices. But the technical definition is the one that I actually prefer, being more of a technologist, which is that passkeys are any discoverable FIDO credential. Now, what this means is that the credential material itself is stored on the hardware key or the device, or within, as we'll talk about in a moment, the sync fabric of a syncable passkey. And that means that the private key, the user ID, and other metadata that are part of this credential are stored physically on that hardware device or within that service. Another way to look at this is as a Venn diagram. And I like this Venn diagram because it begins to show the similarities between all passkeys or all FIDO discoverable credentials, the fact they're all cryptographic key pairs that are origin bound and highly phishing resistant. Generally, we think of them as password replacements, though we certainly have seen them used as second factors. And they may or may not be attestable, which is some additional metadata about the authenticator itself that can be used in certain environments, particularly in high assurance environments, to ensure that an authenticator meets the needs of the RP. But let's talk a bit about what the difference between synced passkeys and device-bound passkeys are, because it is these differences that make a difference when it comes to the decisions we make about deploying passkeys in our enterprises. So a synced passkey is what was introduced by the Alliance and its partners a little over a year ago. I believe it was May of 2022. And a synced passkey is a passkey or a FIDO discoverable credential that is backed up and synchronized across a passkey provider's cloud, or otherwise known as the passkey synchronization fabric. And this means that the passkey that I create on my phone on the left side, say this phone is an iOS device and it's bound to it's bound into iCloud, which is Apple's passkey ecosystem. The credential I create on my iPhone on the left will be synchronized to iCloud and then synchronized to my other iCloud synchronized devices, my iPad, my MacBook, etc. And this is fantastic because it brings a high level of durability and recoverability to these credentials. Now, the provider itself may be the platform or the OS vendor, so Apple, Google, and Microsoft, or it could be from a third-party provider, what we traditionally called a password manager, but maybe now we need to start calling them credential managers or even wallets. And this would be the 1Password, Dashlane, Bitwardens, and others who have served traditionally, again, as password managers, but are migrating into this passkey space. Now, with this synchronization fabric in place, if I need to add a new device to my account, say I've replaced my iPhone with a new iPhone, I simply log into iCloud and follow whatever process is required by my passkey provider, in this case Apple, in order to download all of those credentials to that new phone. Now, this is fantastic because many of the issues that we have with passwords and with passkeys that are bound to a single device are issues with account recovery. Because if I lose that credential or I lose that device, I cannot authenticate back to the service. But in this case, when I have a synchronized passkey, now I don't have to perform account recovery. Rather, I need to perform an action of credential recovery from my passkey provider. So if I say, have my iPhone and my MacBook in my laptop bag, and I throw it into Puget Sound, and I've lost them, once I replace those devices, bootstrap them into the iCloud ecosystem, I can now recover my credentials and log into all of my services. Now, this reduces the need for account recovery from the relying party or the the service itself, but it doesn't eliminate the need for account recovery, as we'll see in a moment. Additionally, the security of syncable passkeys has slightly different properties than, say, a device-bound passkey, because now instead of just the user being responsible for the security of those passkeys on their devices, the passkey provider is responsible for the security of those passkeys within the sync fabric and access to those passkeys in that fabric. Now, a device-bound passkey is what many people think of sort of as traditional FIDO authentication. And this is where the credential is bound into a hardware device. And this may be a trusted platform module or TPM, a trusted execution environment or T, or a secure element. And these credentials cannot be exported under any conditions. And it is these device-bound passkeys that are commonly found on hardware security keys made by a number of manufacturers. But they may also exist on phones, laptops, and other devices. As I noted, there is no backup of these credentials. And in the FIDO Enterprise Deployment Working Group a few years ago, I believe it was 2019, we wrote a paper about backup and recovery for device-bound credentials. And our guidance there is the same guidance I'll give you today, that if you are using a device-bound passkey, your users must register a second, a third, or an nth credential for backup, because without a backup, if this credential is wiped, if the device is destroyed or the device is lost, the user must go through an account recovery process to recover with the relying party. And these processes can be sometimes very challenging. So let's go back to our Venn diagram then and add some color to this Venn diagram. So now looking at synced passkeys and device-bound passkeys, we see some new properties show up. So synced, by definition, have an exportable set of key material. This is the the private key and other metadata that is exportable because it is synced to the cloud. Device-bound passkey, non-exportable key material. And this can make a difference in regulated environments when it comes to whether or not these credentials are usable in each of those in those high security environments. Now on the bottom, we see, as I mentioned, credential recovery via the provider for a synced passkey, but a device-bound passkey is unrecoverable if lost. However, a user could delete their synced passkey from their provider, so we still must provide account recovery via the relying party, regardless of whether we're allowing device-bound passkeys, synced passkeys, or both in our environment. The other difference I'll note here is the availability of what is known as credential sharing with synced passkeys. Now, certainly I could buy a hardware security key, I could create a credential on it, and I could ship that to somebody else as a way to share it, but that is not very easy to do. There's an expense with it, etc. In the iCloud ecosystem today, you can use AirDrop to share credentials with other folks in local proximity who also have iOS devices or Apple devices, I should say. But I do expect we'll see more kinds of credential sharing in the future. And in fact, Apple has announced this recently at the Worldwide Developers Conference, coming with iOS 17 and their upcoming set of operating systems. Now, as I look at the security spectrum of these four kinds of credentials, what we see is moving from the left, lowest security, moving to the right, we get higher security, is that passwords sit all the way to the left here. We think of these as a relatively low security authentication credential. If we add legacy MFA, we can certainly increase the security of that credential. We can further increase the security of that credential with risk-based authentication or other mechanisms. But it is clear that synced passkeys and device-bound passkeys are much more secure on this spectrum than any password-based authentication. However, synced passkeys are not as high on the security spectrum as device-bound passkeys. And that's okay, because not every system requires the highest authentication assurance available. But for those that do require that high authentication assurance, device-bound passkeys are generally the mechanism that you are going to choose. But you should be aware that even within the device-bound passkey space, there are differences that can make a difference, such as whether or not the authenticator meets the requirements of FIPS 140-2 or FIPS 140-3, which may be needed in certain regulatory environments. And this is discovered based upon what are known as attestations, which are statements of fact about these authenticators that can be collected at registration time. In the high assurance paper by Sean Miller, he talks about this quite extensively. So let's take a look at what it looks like to log in with a passkey. And so this video is produced by my friend and colleague Shane Whedon from IBM. And what he's going to do in this video is show you logging in with a passkey. This is on Safari on Mac OS to kayak.com. This is the Australian version of kayak.com. But let's run the video here and you'll see what happens. So Shane is going to go to sign in. And when he clicks continue with email, autofill pops up with his passkey for this website. Now on the right, you'll see he'll do Touch ID. That will locally identify Shane with his biometric. Use that passkey to sign the challenge, and Shane is logged in. And I apologize that the screen has gone blank here. Now, this is only one way that we might actually log in with a passkey. There's a second way as well, if I can get my slides to move forward here. There's a second way, which is known as the cross-device authentication flow, and this allows a cross-ecosystem experience. Now, I'll show you an example of this, but maybe you have a passkey on your iOS device, and you're sitting down in front of a Windows machine that doesn't have a passkey established on it. Or maybe it's another Macintosh that, again, doesn't have a passkey established on it. We can actually use this cross-device authentication flow to do authentication on the laptop or the desktop that's sitting in front of us that does not have a passkey without ever transferring the credentials to that device. But once that laptop or desktop has been authenticated, now we can bootstrap a new passkey or create a new passkey on that device so that we never have to go through this flow again if that is the end state desired by the user. So again, Shane Whedon produced this video, and you can see on the left, you've got I believe this is Safari on Mac. I'm sorry, this looks like Chrome on Mac OS. And on the right-hand side, we have Shane's iPhone. And we're going to see what this flow looks like. So again, Shane's going to click sign in. But as he goes to enter his email, you'll see there's no autofill. And when he clicks, it asks him if he wants to use a passkey on a different device. And here it brings up a QR code, which Shane is going to scan with his phone. The phone has the passkey. It asks him to sign in with it by signing in with Touch ID. He does that, and then automatically he's signed into kayak.com.au. Now, what has happened in the background is using this QR code, Shane was able to establish local proximity of his phone and his laptop. And this is an important security control to ensure that this can't be attacked remotely. But the actual authentication is taking place on a network transport from his phone to the relying party server. The credentials are never transferred to the Chrome instance that he was signing in, that is being signed into Kayak. Again, those credentials never move onto that instance of Chrome, but we could create new credentials on that instance of Chrome if we desired. So let's move on and talk about the papers. So back in October of last year at the Authenticate 2022 conference, we also had our FIDO plenary session where the Enterprise Deployment Working Group met and started talking about producing a paper around displacing passwords in the enterprise with passkeys. But there was so much excitement within the EDWG at this time that what was coming out of that meeting, one paper, quickly ballooned into a series of 5 papers covering deployment of FIDO authentication solutions to meet low to high assurance use cases in enterprises. Now, when we speak of enterprises, you might hear enterprises of thousands or tens of thousands of people. But in fact, these mechanisms work for enterprises that include small and medium-sized businesses that may be in the range of 50 to 100 people or 100 to 1,000 people. And all of these techniques are available across all sizes of enterprises. So let's look at what the papers are themselves. So the first paper is an introduction to deploying passkeys in the enterprise. And this paper should be read by everybody on the call today. Our intention is that this sets up the framework for the rest of the papers that we're delivering and gives you some guidance so you, as the reader, can understand which further papers you need to read that map to your specific environments. The second paper, written by my colleague Khaled Zaki, is considerations for replacing a password-only authentication with passkeys. And so for those of you who have users in your enterprise that are only using passwords to authenticate to one or more services that they use on a regular basis, we would like to help you displace those with passkeys for a more secure, more seamless, and more reliable authentication experience. The third paper by Jing Gu at Beyond Identity and Josh Signa at Ubico is still in the queue and will be released in a few weeks. However, this paper covers displacing passwords and SMS OTP authentication with passkeys. So maybe in your company, you've deployed SMS OTP, a virtual OTP with a virtual authenticator app, or even an email OTP, or some other OTP-like mechanism to reduce the risk of credential stuffing. Well, in this case, if you're not under regulatory guidance to use multi-factor authentication, and you may be able to displace this password and OTP authentication with passkeys, still avoiding the credential stuffing while providing, again, a more secure and seamless experience for your users. The fourth paper is Passkeys for Moderate Assurance Enterprise Environments. And this was written by Jerome Beckhart from Axiad, who will be speaking today, as well as Greg Brown from Axiad and Matt Estes from Amazon Web Services. Now, in this paper, we get into a discussion around passkeys in enterprise environments where you may have low assurance requirements and you may have some higher assurance requirements that you may need to differentiate between in your use cases. So some users may be able to use synced passkeys. Other users may be required to use device-bound passkeys, or even device-bound passkeys which meet certain regulatory requirements. And in the final paper, Passkeys for High Assurance Enterprise Environments, written by Sean Miller at RSA, Sean writes about how we can deploy passkeys in these highest assurance environments where we need to meet certain regulatory requirements or compliance requirements. Again, I'll use the FIPS 140-2 example and using FIDO attestations at the registration event of a new credential in order to establish that the credential meets this particular high bar for your regulatory environment and is usable within this environment. And so I'm very excited that we were able to release 4 of these papers 2 days ago. As I mentioned, the Displacing Password and SMS OTP Authentication with Passkeys paper will be coming shortly. And I look forward to the feedback from the audience here today, as well as others, as you read these papers, digest them, and understand how they fit into your environment. And with that, I will say thank you very much for your time. I appreciate it. And again, I thank all of the authors who've written these papers and members of EDWG who've done a lot of great work in reviewing this data, reviewing these documents, and ensuring we can release a body of work that we all can be proud of. And with that, I will turn it back over to Megan.